This is lesson 3, and it's all about the electromagnetic spectrum. So the electromagnetic spectrum is a spectrum which consists of 7 different types of waves, and they are all consisting of electric and magnetic fields, and that's why they're called the electromagnetic spectrum, and they all belong to the spectrum. And they've all got different properties and different wavelengths, but they have things that are similar to them, and we'll have a wee look here and see. So this is the true-false activity. Light is a type of radiation, and it's part of the electromagnetic spectrum. So we know that that is true, so we're going to underline that. The electromagnetic spectrum is made up of different types of radiation. That's also true. The different types of radiation have different properties and behaviour, so we just said that. All electromagnetic waves can travel through space. Now, if we think about light, we know that that is true because light is an electromagnetic wave and it can travel through a vacuum to get to us. So that's also true. And then the last one then, all electromagnetic waves travel at the same speed in a vacuum. And that's the speed of light. That's 300 million metres per second, or 3 × 10⁸ is another way of writing it in standard form. And that's also true. Okay, so although all electromagnetic waves travel at the same speed, their wavelength lambda and frequency f can be different. So waves that cook food, such as microwaves or infrared radiation, which is a type of heat radiation, have a fairly long wavelength. So from there to there is their wavelength. Whereas waves which cause suntans, and those would be an example of the ultraviolet radiation or ultraviolet waves, they have a shorter wavelength, and they're actually a little bit more damaging to us, the ultraviolet ones. The properties, dangers and uses of these waves depends on their wavelength. So there's lots of different varieties of wavelengths, and they go from very short wavelengths to very, very long ones. And this shows them all on the one page, but really in terms of scale you couldn't really show the length of a radio wave and compare it to the length of a gamma wave, because this is so tiny and this is so huge. So this is really just showing that the wavelength is getting longer as you get to this end. So if I just turn this round a second just to see, the very short ones are gamma, the next ones are X-rays, ultraviolet, light, infrared, microwaves and radio waves, and you need to learn them in that order. And if I turn this round again, you can see the ones at the left hand end, the gamma ones, have very high frequencies. That means there's lots and lots of them. If you look at the wavelength, and you can see that if you had a screen, you would have lots and lots of waves shown on the screen. They have a very short wavelength, and this is probably the most important thing about them. They have very high energies and they're very, very penetrating, and that makes them very dangerous. At the other end, the radio waves here have got low frequencies, long wavelengths, sometimes up to 1 kilometre in length. They have low energies and they are the least penetrating, and that's why sometimes you can lose your radio signal when you go into a tunnel or into a valley or something like that, where the radio waves can't pass round, and they are less penetrating. So they have to pass round things or through a space to get to somewhere, whereas these can actually pass through most matter, including things like aluminium and even lead. Some of them can pass through lead. This is just a little mnemonic just to help you remember it. Remember the order. Gate X usually lets in most radiation. So G for gamma, X for X-rays, U for ultraviolet, L for light, I for infrared, M for micro, and R for radio. So we'll just go through each one, starting with gamma. Gamma's the one with the shortest wavelength. It's used to kill harmful bacteria in food, to sterilise surgical equipment, and to kill cancer cells. Dangers: if you get too high a dose, they can kill cells. Lower doses can cause cells to be cancerous. So they are a very, very dangerous type of radiation, and you should never be exposed to gamma rays unnecessarily. X-rays are next. They have the second shortest wavelength. They are used to take pictures of the human bodies, probably the most common one, and they're used to take photographs of bones. They also take pictures of luggage in an airport. Sometimes they are used at the docks to look at cargo containers, to take x-rays of what's inside a cargo container to see if there's anything in there that they would need to open up the container and look at. Dangers: high doses, again, like gamma rays, can kill cells, and lower doses can cause cells to become cancerous. So you'll only get an x-ray if it's absolutely necessary. If they think you've broken a bone or something like that, you'll not get too many x-rays at the one go, because it can cause cancer and things like that. Hospital workers who work with gamma and x-rays have to take safety precautions. They stand behind lead shields whenever they're operating the x-ray machinery, or they have to leave the room when the radiation is being used, because obviously we might only be exposed to it for a short period of time, but they're being exposed to it every day, a number of times a day, when they're taking x-rays and gamma ray pictures. This is a picture of an x-ray, and this is the idea of the shadow effect. The really dense parts of our body, like our bones, come up very, very white, and the dark areas are the places where there's a lot of air. And so you can see here, this is a picture of somebody's lungs, and this is where their heart is there. You can see the shape of the heart. This, when you're looking at this picture, you see the heart on the right-hand side, but an x-ray is a mirror image, and so this is actually the left-hand side of the body, and up here you can't see, that didn't come out there, but there would be a wee L on each photograph just to show which is the left and which is the right. And so this is on the left-hand side. So x-rays can penetrate soft tissue but not bone. X-rays are absorbed more by some materials than others, and so bone would absorb x-rays. And photographic film is used to detect x-rays. Right, the next type of radiation with the next shortest wavelength is ultraviolet. Ultraviolet is used in sunbeds, in fluorescent lamps and security markings. So they can look at, under an ultraviolet light, you could look at, say for example, a note, a Bank of England note or a bank note, and they would have some kind of fluorescent marking which we couldn't see with the naked eye, but which is obvious under fluorescent light. And so if it was a forgery, it may not have that ultraviolet marking on it. Dangers: high doses can kill cells. Lower doses, again, can cause cells to become cancerous. And so that's another danger of ultraviolet. And we know that can cause skin cancer. It's not just as dangerous as gamma or x-rays, but it can cause skin cancer, and we know that. So some effects of electromagnetic radiation on living cells. Ultraviolet radiation can pass through the skin to deeper tissues, and this is a problem. What effect do you think the colour of the skin has on the amount of radiation that passes through it? If you've got dark skin, in other words, if you have black skin like in hot countries, then obviously the amount of radiation hitting it there, the amount passing through is much less, because black absorbs light much better than white skin does. So white skin people are at much more risk whenever they are lying out in the sun trying to get a suntan, because more of the radiation will be absorbed by the lower layers of skin, and that could lead to skin cancer. Right, the next one is light, and this is one we're most familiar with. And light is obviously the only one that we can actually see. It's only one of the 7 types of electromagnetic waves that we can actually detect with our eyes. Uses are for seeing things, to illuminate things. You can use them in an endoscope. An endoscope is a tube which is curved, and you can get the light to reflect inside the tube all the way down to the thing that you need to look at, and then you could have another tube beside it and it will reflect the image back up again. So for example, they use that to look down into your stomach. They put the tube down your throat, down into your stomach, they shine light down through it, and then the light's reflected from anything that's in there back up again, and the surgeon can see that, and that's called an endoscope. Dangers: obviously too much light can lead to blindness. Infrared radiation uses are for remote controls for your TV, your video, for your Xbox. Radiant heaters, so any heaters that give out some heat would be giving out infrared radiation. A grill in your cooker. It's used for optical fibre communications and also used for night vision. So anything that is warm gives out some infrared radiation, and if you use an optical vision camera, night vision camera, you can pick up that radiation using an infrared camera or infrared goggles. Dangers, of course, is that, if you're talking about something which is very hot, giving out infrared radiation, it could cause burns. Just a wee bit more about night vision. All objects above absolute zero emit infrared radiation, including us. We're at 38 degrees C, so we give out heat. The hotter an object is, the more heat radiation it emits. Some animals and cameras can detect infrared radiation and are able to build up a heat picture. So the question says, what are the hottest or coolest parts of the image shown? And you can see that the light areas here are hot and the dark areas here are cold. It's difficult to see what that image is of. It looks like it's of a deer. You can see the horns there. Not just quite sure about that. Next one then is microwaves. We're all very familiar with that for cooking purposes. And those are the microwaves that are used for cooking in your microwave oven. They're also used for satellite communication. For your mobile phone uses microwaves and for radar. Dangers are internal tissue heating. So if you put a chicken into your microwave oven, it cooks the chicken because it heats up the tissues. And therefore, that is a danger that if you're holding a mobile phone to your ear for a long period of time, it could be cooking the tissues behind your ear or in your brain. There's just a little bit about how microwave ovens work. Microwave ovens can be used in cooking because many foods contain water molecules. Microwaves of the right wavelength are able to make the water molecules resonate or vibrate, and this causes the food to get hot. Radio waves are probably the most common. They've got the longest wavelength. They've been around a long, long time, and people have known about them a long time. They're used for communication and astronomy. Communication obviously being for our radio signal, and our TV signals are long radio waves as well. There are no real known dangers because they have very low energies, very long wavelengths. They're not penetrating and they don't really cause us any harm. How do radio signals from the UK reach around the globe? So if you have got your radio signal being given out by your transmitter tower, what happens is the radio signals, they travel in straight lines, but when they hit the outer atmosphere, the ionosphere, they're reflected, and they do that round to the place where you want to receive the signal. And sometimes our microwaves and so on, rather than being reflected by the ionosphere, they're reflected by satellites, similar kind of thing. How can houses in the shadows of hills receive a radio signal? Sometimes radio signals, like all electromagnetic radiation, travels in straight lines, but some of those signals then can bend very slightly round a corner. It's called diffraction. So sometimes you might get a signal there even though you should really be up here before you get the signal, but sometimes because the radio waves have bent around the hill or bent in around the valley, you will get a signal where you maybe would expect not to.